This is a universal testing machine made by Tinius Olsen, about 1970 vintage. Universal testing machine means it can do a variety of tests. It can do compression testing, bend testing and tensile testing. They're mainly used for tensile testing, which is what we're going to do this evening. This is another universal testing machine, much older, from about 1940, an Avery machine. Again, it will do a series of tests. It will do compression testing, it will do bend testing, but as I said, it's also mostly used for tensile testing. This particular one, we use a lot of full section plate and full section bars on it. It's set up to do those sorts of samples. This is our second round of tensile testing. Tonight we're going to test more realistic samples, more real world, and we have some specimens prepared, two here. First one is a 1040 steel, which has been normalised, and the second one is an aluminium copper alloy with 3% copper, which is an age hardening alloy which has been heat treated. You'll notice that the samples have been machined. This section here represents the original gauge length, and it is a proportional test specimen. By that it means that the actual gauge length is 5 times the diameter. That is exactly the same as 5.65 square root of S0, which is the original area. So according to AS 1391, we use a proportional test piece where the gauge length is 5 times the original diameter. And there are some centre punch marks here. They are stamped at 50 millimetres. So the actual original diameter is 10 millimetres and the gauge length is 50 millimetres for both samples. So the aluminium one is stamped as well, and the steel is both stamped. They are important for us to work out our elongation once we have finished the test. So this sample is the age-hardened aluminium alloy, and you can see it's held in the collets here. In between the sample, there is an extensometer there, which is an electric extensometer, which actually powers the drum over the other side here, and the drum rotates as the extensometer extends, and with the applied load, this needle moves up here, and as the needle moves up, we get a reading of the load. So we're going to produce, again, a force extension curve. This sample is the age-hardened aluminium alloy. As a non-ferrous alloy, it doesn't show a distinct yield. Because it doesn't show a distinct yield, we need to calculate a 0.2% proof stress. So for this material, it's very important to actually have the graph, so we can do some calculations from the graph as to the load of proof in order to work out the proof stress. You should notice that the slope of this particular graph is shallower than the steel. Indicating a lower smoothness. dial's starting to slow down and the graph is starting to show a change. So we've actually got to the limit of elastic behaviour. We are now starting on plastic behaviour. So that again is around 25 kilonewtons. According to the Australian standard, we are to maintain a set strain rate below the yield until we've actually yielded. Beyond that point, we can actually increase the strain rate. Probably won't pour as much as the So the sample should be starting to neck now, getting ready to break.